Hi, everybody. Today I'm here with Cal Zirilli. He is a researcher. He graduated from the University of Louisville, um, as well as spending some time in industry. And now he's a Fulbright scholar where he is in Santiago, Chile. And afterwards, he's going to start working towards his doctorate at Columbia University. Cal, thanks for being here with me today.
Of course. Thank you very much for having me.
Um, So, obviously gave a little brief intro to everyone about you, but is there any more background information on yourself you want to give the audience, or just kind of a little more in depth?
I would like to clarify since I know that you've had some more some real PhDs on your on your show before. I have just a bachelor's degree right now. I am in the very early stages of my career. I got my Bachelor of Science in Chemistry and my Bachelor of Arts in Spanish from the University of Louisville. Um, Worked for a brief period in industry, making some solar panel materials with a company in Louisville, and now I'm here on a Fulbright scholarship. So I think you actually did kind of hit the nail on the head with
Oh,
your introduction.
well, perfect. Well, I think, even if you like, you're going to do your do like more formal part of your doctorate after this, think people will be really interested to hear about your Fulbright scholarship and kind of the road you've taken, because I don't think anyone truly takes a standardized road in STEM. It's always a little different.
Yeah,
So,
most definitely.
you're in, like I said, you're in Santiago right now as part of the Fulbright scholarship. What kind of work? What are you working on right now? Like, what kind of science in your mind like do you do when people ask? So,
Yeah. I'm an inorganic chemist. I work, with metal complexes. Specifically the lab I work in works on kind of two different routes. So they do synthetic inorganic chemistry and they do inorganic photochemistry. And they actually align in a way that I think is very interesting. So if we're going a little bit into the weeds here, um, we make metal helicates, which are a form of metal complex that have a helical structure, and they have an interaction with DNA. And the reason why they overlap with the photochemistry aspect of it is because of we can take advantage of that interaction with DNA, or at least we think, sometime down the line, where if we irradiate them with low energy red light, we can generate reactive oxygen species to kill cells. And the idea is that, X-rays for photodynamic therapy for the treatment of cancer right now can cause more cancer, and that's obviously not
yeah.
good. But if we use red light and a photocatalyst, we can still kill cells, kill cancerous cells, but without having the extra damage that X-rays carry.
Okay, that's really interesting. I find that whole kind of concept of like that interface of chemistry and medicine so very interesting. Actually, the first research I ever did, it was honestly at this point, it was research what I knew research was at the time. It was some
Mhm.
undergraduate research I did. It was a synthesis of like nitrogen containing analogs of like cantharidin for use as like radiosensitizers for to they were my I'm sorry, the department head at my undergrad. A lot of his work was in that, and he had developed a bunch of these molecules that essentially made the cells more susceptible to any radiation, but like only cancer cells. So it's interesting. You
Interesting.
can do, yeah, you can do it with metal complexes as well, but it
Mhm.
makes sense. But also, you got to try everything. I feel like sometimes science is like people don't realize how much we just throw at the wall to see what sticks just a little bit, and then we run with that.
Yeah.
But that's awesome. Well, you kind of answered my next question with a little more, which was just based a little more in depth on your specific research, but you kind of knocked that one out already.
Forgive me.
So, but while we're on the topic of your field, what do you think something that people like most misunderstand about your field, whether it's the just, the kind of broad inorganic chemistry standpoint or like the more medicinal applications and interface?
I think that probably the most misunderstood part about I think just being a chemist in general is that it's a solitary pursuit.
Hmm.
I think There are vanishingly few instances in the life of a chemist where you are truly going to be working on something entirely alone. Almost always you are going to be part of a team. You may or may not have an advisor. Like if you're in industry, you might have a boss who's not necessarily like, he might not be like as in the weeds in the science as you, but you're always going to have a team. There might be a portion of a paper that you work on alone that's like specifically your thing or your synthesis, but even still, you're going to have lab mates that you're going to bounce ideas off of. And when you hit a wall, it's always a good idea to go talk it over with someone else who might have some experience in the solving the type of problem you have. Um, just about every single synthetic step that I have taken in my lab right now, like I have talked it out with some of my lab members before actually running the experiment, and it's just useful to have a second set of eyes on it. And I think the other thing is that like the purpose of science is not just to do cool things in the lab, but it is to add to the net sum of understanding that we have as a species. It's like it's um, to advance mankind in a
Mhm.
sort of. I know that sounds a little bit a little bit
Yeah.
grandiose, but it's true. We are trying to work towards something greater, and the only way we can if the purpose is to work towards something greater and to benefit all of mankind, then we need to also, as scientists, be able to share our findings. And I think it was who was it? I think it was Newton that said, like, I stand on the shoulders of giants, and that's the way I
Mhm.
feel too. When I'm in the lab, I'm building on the work of those who came before me, and I'm going to leave something behind to those who come next. And that's the point. That's why we publish
Mhm.
papers. That's why we attend conferences. It's so that we can share our findings with other people.
I think that's an absolutely great answer, and I think that's really good for some people to think about if they want to pursue a degree in chemistry or not chemistry, I'm sorry, just pursue a STEM career. Because I know, especially when you start, it can feel overwhelming. You're like, I have to do all this, or and it's like, hey, like you said, you don't have to do this from scratch. There are literally hundreds of years of scientists that have paved the way for you to make even greater contributions. And also to remember that at one point, like that big contribution we think about at the time might have not have been thought like that big a deal. He's like, I mean, I made this, but whatever. And so what you think of right now, like to you, like maybe you got your paper or you defended your dissertation, but you're like, it's not that big a deal. I'm proud of it. But there might be someone 50 years from now that like they can look down the road, like this is where it started. Does this idea led to that idea, led to that one, to that one, to that one? Um, I have
Yeah.
so it's interesting. You said I met with I did a lot of oh my God, blanking. It's my own project. I'm blanking on what it's called. Olefin metathesis with ruthenium catalyst. And I got to meet Amir Hoiveda one time, and which was really cool. That was like meeting like a rock star. But he said that when they developed the Hoiveda Grubbs generation catalysts, that he didn't even think they were worth publishing. And he
Are
was
you
just like,
serious?
I'm probably not correctly capturing what he was trying to say, but it was his grad students that were like, no, we need to publish this. But he was saying how he was glad he trusted them, and that's like one thing he would impart is to like trust your grad students and always support them. And so
Yeah.
they published this, and this it developed a whole new generation of olefin catalysis. And
That's incredible.
and he's like, it's to think that I thought like he's like not that I thought it was bad work, but I just was I don't want to put words in his mouth. So I don't remember exactly what he said, but he said like, yeah, I almost didn't publish it. Like,
That's wow. Dude, science is such a small world because like the Grubbs catalyst is genuinely one of my greatest inspirations for chemistry because I remember I took an advanced organic synthesis class and they
mhm,
were talking about ring closing metathesis and about how it revolutionized the field of synthetic organic chemistry. And I was just like, that is so cool. I think I should like wow, that is such it's so crazy how small of a world science truly
yeah.
is.
And speaking of Bob Grubbs, I never got to meet him, unfortunately. He died, I believe, in 2021, the year I started my PhD. But you
Oh,
talk about standing on the shoulders of giants. Apparently, like he was just, you could just call him and be like, maybe not literally call him, probably email him. But for the sake of like when you tell the story, and he would just be like, "Well, what are you working on? All right, let's see if I can we can work it out." You know what I mean? Like apparently he
Yeah,
was just willing to give information help to everyone. It was just
that's so
everyone I've
cool.
met that knew Bob Grubbs just speaks so highly of him, and it's so weird. It's like I feel like I missed. It's like weird to mourn a guy I never got to even meet. It's like,
Mhm.
but
Yeah.
yeah, and then the more I read about his stuff, it's more. I was like, dang, this guy was smart. But you know,
Yeah.
yeah. But sorry, before I get off on a whole tangent about ring metathesis and Bob Grubbs. Um, but so you're not starting your PhD yet. You're going to Columbia after this. But what made you want to pursue a PhD?
See, I have always wanted to be a scientist.
Hmm.
Genuinely, since I knew what the word was, I was like, I think it was because my mom took me to the science center a lot as a kid. And I just like have always had a fascination with it. My mom also is like a science teacher. She teaches biology at a high school. So I was kind of primed to be a
Yeah.
scientist, my whole life pretty much. Um, but yeah, I personally can't imagine myself doing anything else. I just love science so much. And I think chemistry in particular has something that just really clicks for my brain that is really satisfying. So,
Well, that's great. I understand that. And what you kind of got into the next question was how'd you get started in STEM? But it seems like your mom was a biology teacher. She took you to the science museum a lot, and that's how it she got you from a young
yeah.
age.
Yeah. I mean, I kind of always knew. It's not that I didn't like my other classes, but when I was a kid growing up, I just felt sciences felt this feels kind of strange to say. They were like almost easy in high school. Like
I know what you mean. Yeah.
I never struggled with the high school science classes. They were just fun. They were satisfying.
Hmm.
And I always when I got something wrong in a science class, it was like exciting. And then I would figure out how you actually solve the problem or what the correct answer was. And it was mind-opening. And I would go home after class and I would be thinking about it. I remember one time I was um I was spending time with this is a crazy tangent. I was hanging out with my girlfriend in high school. Um and I was just kind of staring off into space and she was asking like what I was thinking about, and then I kind of came back to reality, and I said that I was thinking about osmotic pressure, and how like you can calculate the if you have a U-shaped tube and you have one side with salt water and one side with pure water, you can calculate like the difference in the height on the side because of osmotic
Yeah.
pressure. And it's like that's such a I'm such a loser, you know? Like
Yeah. No, I don't know if I've ever done the osmotic pressure one, but similar to you, I got involved in science at a young age, and nothing even like at the appropriate level for like a child. But my parents always took me to like science museums, like natural history museums. I really credit the Franklin Institute in Philadelphia. It's like an interactive science museum. I don't know if you've ever gotten to go, but I credit that with getting me involved in science. And then Bill Nye the Science Guy. I used to be really into him.
yeah, Bill
Um,
Nye's cool.
but yeah, no,
Um, yeah. I would say also when I got into my undergrad, I knew I wanted to get into a research lab as soon as possible. Um, and I think having like a good mentor is very important. I got a scholarship that was for people that wanted to do research, and so it was perfect for me. And they really pushed me to get started. And I honestly, I started in inorganic chemistry kind of just by chance because I talked to a professor who happened to have an open space in his inorganic lab.
Mhm.
Um, and so I started with him immediately. But if I really think about it, I think I would have ended up in inorganic chemistry anyway because I think
Yeah,
it has everything that I love the most about chemistry. It has this, I really love synthesis, and
yeah,
I love catalysis and all of that. And I think inorganic is great because you have the synthetic aspect of it where you need to know organic synthesis to make your ligands, and then you need to
hmm,
obviously know inorganic synthesis to know how they're all going to bind and all of that. But then you need to understand like the quantum chemistry aspect to predict like the properties and the energy levels of the d orbital splitting and all of that. And I think there's something very nice about inorganic chemistry where you need to know it's you combine knowledge from all forms of chemistry into inorganic.
Yeah, that is true. I had a couple friends that were they were synthetic inorganic, and yeah, they were. I always felt that they had a better grasp on more areas of chemistry than me because they kind of need to. Like
Yeah.
or organic chemistry, it's like, okay, I got s orbital, I got my 3p orbitals, we're
Yeah.
good,
Yeah, but you
call it a
guys are
day.
you guys are wizards though. Like I don't know how you can make a natural product. That's insane.
I don't know.
Like, dude,
Sometimes
I see where you get like four different protecting groups, and then it's like, how are you even doing that, you know?
I'll be like, so, I consider myself a synthetic organic chemist, but I got to be honest. Like, I always tell people, like, there's levels to this stuff, and there are some people that are just levels above me. I'll look at their synthetic schemes, like in these papers they published, and I was like, that is just like, what were you doing when you thought of this? Like you hear the old stories of people that were like the things come to them in a dream, or they took some sort
Yeah.
of like old timey like hallucinogen, and that's what they thought of. I was like, you must have been like what were you doing, like peyote in the desert or something? And this came to you. I mean, but some
Yeah.
people like that's just how they function. But it's yeah, no, some people just make some crazy stuff. But and I don't know how you feel this way, but synthetic chemistry in general, I always told people if they were interested in it, you have to be ready for like manic highs and lows because like a lot of times it doesn't work, but when it works, like
Yeah.
God, is that just the best feeling in the world? You feel like nothing can touch you.
Yeah.
uh,
Absolutely.
um, so we already answered this. So if do you have any advice for any young students that want to get involved in STEM?
I think if you, in my opinion, you need two things to be successful in STEM. Um, you really need to love what you do, and you need to be willing to put in the effort to get to where you want to go. I think there are like I know a lot of people who started, this is more of a problem for engineering, I think, but like I knew a lot of engineers who then ended up switching out of engineering because they didn't really care about the science and they just wanted the paycheck. And
Mm,
that's not like, you know, everyone needs to make a living, right?
mhm.
But I think especially with some of the more like some of like the chemistry, biology, physics, like they don't necessarily pay as well as like as engineering.
Yeah,
Um, and the academic rigor is real, you know. And I think it's not that you can't do it if you don't have a passion for it, but you're not going to have fun if you don't actually love it, you know. And
yeah,
if your goal is to just make money, then you can make money in other ways, you know. And so yeah, I would say that because you need to love what you do and you need to be willing to put in the effort because sometimes it is a slog. Even though I love chemistry so much and I couldn't imagine myself doing anything else, sometimes it is a slog. You know, when you have a 6 hour column and
yeah,
it still comes out impure at the end of it, you know, like that's not fun. That's not fun for anyone.
yeah.
Um,
That's yeah, great advice. You gotta, especially in the way the job market is today, like the advanced degrees of any field don't really guarantee you like a job or a salary the way they used to. So yeah, you really need to like what you do. I think that's great advice, Cal. Um, well, where were we? Oh, what's a piece of advice that you wish someone told you when you were starting your like STEM career or STEM journey?
I think. This is like, it's not particularly profound advice, but like time management and sleep management are very important. Um, like you only get a few hours of intense mental effort every day. And it's good to like try to build the habit of studying a little bit every single day because if you study for 2 hours for like 5 days a week, right? Um, you're going to retain all that information really well. Whereas if you try to study for 10 hours on Friday, you're not going to retain any of it, you know? Um,
Yeah,
and the other thing is sleep. You learn better when you are well rested, and you retain things if you sleep well after you study. Um, and so there are some times where like obviously if you have like an exam the next day and you know nothing, or like if you're staying up to work on a project, sometimes that's different. And sometimes, life happens. But I think being very strategic in making sure that you get enough sleep and that you are well rested, you are going to retain things so much better in the lab or in lecture. And then when you like, you're not going to need to spend as much time studying if you are well rested versus if you know, if you're exhausted and you're trying to study, it's going to take longer for you to study the same amount of content. So
Yeah,
that's my 2 cents.
I would agree for everybody watching, especially like the undergrads, especially I would see it a lot with when 'cause I taught organic chemistry lab, and I would see it a lot. And then just when I was going through my undergrad, I would see it with people like, yeah, sacrificing sleep to, and I really tell people now, like, yeah, especially for like a test, I always say like if you say it's like midnight and you're like, oh, I'm gonna stay up like an extra hour or two to study, like no, go to bed. Those
Mhm.
1 or 2 hours are better spent sleeping, so you're actually rested tomorrow for your exam. That's great.
Mhm.
That's great advice. I think more people need to hear that because I feel like it's something that everyone kind of knows, but they need to hear it probably like 10, 20 times before they actually take the advice.
Yeah. It is the way that goes.
Um, what would you say is the biggest challenge you've had as a scientist?
I think, especially with where I am now, and like this is a common complaint I've heard from other graduate students too, is like trying to understand advanced concepts without necessarily having a solid foundation in the fundamentals, or sometimes switching fields, or you go to certain classes or a research topic where like you might be new, and you don't necessarily know, there wasn't like a fundamentals course for you to take. Um, and so, like, for example, I really struggled with group theory in inorganic chemistry. And that is kind of embarrassing for me to say because group theory is like the foundation of inorganic chemistry. But
Mhm.
like, I would say that in a lot of ways, like some of the more math heavy sides of chemistry, I always struggled with because, I mean, I did well in like calculus 3, but I didn't take differential equations and I didn't take group theory, which is required for inorganic. And so, like, yeah, I needed to kind of teach myself that sort of stuff. Um, and there's like a lot of other things, like when I did my internship with SoFab Inks, which was my industry experience, which I want to talk about a little bit more later. Um, they were making nanoparticles, and I had no experience in nanoparticles, and they were also using it for like solar panel applications. And so there was like a lot of electrochemistry stuff and stuff that was like very engineering focused that like I had no background in. And I had to teach myself. Um, and I think that's it's a skill you develop being able to teach yourself certain things. And I think that it builds resilience and a kind of confidence that I think is very valuable. Like knowing that no matter what challenge your career is going to throw at you, you're going to have to figure it out. And then having the confidence and knowing that, hey, you are going to figure it out. You just need to put the effort in. That is something that I think is very valuable. Um, so yeah, in conclusion, the big challenge is sometimes, you know, you get presented with these obstacles and you have to figure it out yourself.
Mhm. I think that's something that, yeah, I know exactly what you mean, especially if you're going to go into the higher level of any field, whether it's chemistry, engineering, material science, at a certain extent, yeah, even if you don't know it, you're kind of expected to get yourself up to speed. So now I talked about your challenges. What's the favorite part of either, your field, your research, it could be any of it.
Dude, exactly what you were saying earlier. When you get 88 milligrams of a pure white powder and you take the NMR and it comes out clean and it's exactly what
Yeah.
you wanted. Oh my God. It feels so good when you have a synthesis that works and it's just beautiful. So that I get a lot of satisfaction out of the like day to day in the lab,
Mhm.
making a little bit of progress each day. That is very satisfying to me. But I also I think like on a more macro like philosophical way, I think that like learning more about how our world works and contributing to this wealth of knowledge that we as mankind have is very gratifying. And I think like especially with me being in another country right now, I think something that's been very beautiful is to see how like the love of science is something that really transcends any cultural barriers, any cultural or linguistic barriers. Like all of
Hmm.
my friends, when we talk about why we love chemistry, it's the same thing. I feel, like we might be speaking in Spanish, but it's the same. No matter where you go, there are going to be people who love talking about science and people who wants to do good for the world and to do good for
Hmm.
mankind and to push us forward and to find new medicines or to find whatever it might be. And I think that is really exciting to meet other scientists who also wants to do good for the world.
Hmm. Yeah, that is, yeah, I agree with you. It is something that truly transcends any cultural, linguistic barrier. Um, so after you're done your PhD at Columbia, do you have an idea of what your kind of your aspirations are? I know you're pretty early on, but are you leaning one way or the other, like industry versus academia, or what are you thinking?
Yeah, I'm not really sure right now. I think I do lean a little bit more towards academia,
Hmm.
because I I do like to teach. I mean, I used to tutor organic, and that was really fun. And I am really excited to talk about chemistry, and I think it would be really fun I think it'd be cool to teach chemistry because then I'd get paid to talk about chemistry all day.
Yeah.
But I don't know. I might work in industry. It sort of just depends. I
Hmm.
also really love working in the lab. Of course, I mean, I'm a chemist. So I think being in academia would be good. That the one downside with being in academia is that like after 5 or 10 years, like you kind of become more of an advisor and less of like a hands-on in the
Hmm.
lab, which is like
Yeah.
kind of a downside for me. But I don't know, maybe I'll work in industry for a few years and then switch to academia or vice versa. I don't know.
Yeah, and I feel like it's something that kind of changes over time, like, or you might, depending on the season of your life or what's going on, you might change your answer at that any given time, what way you lean. So, I mean, you got time. Yeah.
Mhm.
Um, so we already answered that one. OS. Um, well, the viewer writing question wouldn't apply to you, but so let's talk about you said you wanted, I forget what you said you wanted to talk about. Oh, is your
Yeah.
internship?
Yeah.
Uh,
So go ahead.
yeah. I was like, yeah, why don't you tell us a little more about that?
Yeah. So I mean, the main thing I wanted to bring up about the internship, and apart from the fact that it was very valuable, it was like a new form of chemistry to me. Like I said, they were doing nanoparticles for solar panel applications, and I think that that was very fascinating because I never worked with nanoparticles, and it was very much like a cross between typical like inorganic chemistry and like material science, which was a little bit outside of my field. But the thing I really took away from it, um, and this was not something like that surprised me, but it was something that was confirmed for me in a big way, is just how interconnected the scientific community is. Um, because they had almost all of their connections, like with other labs, were abroad. They had collaborators. Their three biggest collaborators were in Italy, in Japan, and in Saudi Arabia. And they had, they would always go to these conferences in Europe and in Asia, or wherever it may be, and they would present their findings and what they like the products they were selling, and they would try to get these companies on board to like collaborate. And I think it was a way, I've always felt that collaboration in the sciences is like the way forward. I'm sure that we've all had that's probably clear from the way that I've been talking already.
Yeah.
But it really did confirm in a big way that just how important it is to like be part of the scientific community and meet other people, um, and to be able to connect. And I also think okay, listen, I'm very obviously biased. This is going to be kind of another tangent. I think it's very important for scientists, especially in the US, to value learning another language.
Hmm.
Again, I'm biased because I did that. I have a bachelor's in Spanish as well, and I'm currently researching in a Spanish-speaking country. But I mean, if you look at just about any PhD program around the world, almost all of them will require you to learn another language to at least like a basic proficiency. Usually it is
Mhm.
English because English is kind of the lingua franca of science. But I think learning another language makes you, it opens your mind. It makes you more curious about the world, and I think it gives you the opportunity to meet and collaborate with other scientists everywhere. And of course, like I said, English is kind of the lingua franca of the sciences, but I think you can connect with scientists on such a deeper level if you have if you're fluent in their language.
Mhm.
And there are a lot of people I've met here who like, I don't know, I just feel like being able to speak chemistry in Spanish with my friends has really helped our like friendship. And I know that I'm gonna like keep in touch with them, like in
Mhm.
10 years after I'm done with my PhD, I'm sure that we're gonna publish some papers together at some point.
Mhm.
Um, and there was something else I was going to say, and I'm blanking on it right now.
That's
Um,
all right. Yeah, that's good. I agree. Definitely worthwhile. I think is try to learn to some degree any language you can, especially in like since I live in Texas, like Spanish is like the easy one to learn. Well, because there's
mhm,
a lot of Spanish speakers in Texas, and also you're right next to a bunch of you're very close to Mexico. Mexico does, and then all the other than I guess like Canada, it's all the closest other countries speak Spanish pretty much, and oh, there's some islands in the Caribbean that maybe speak some they're either English speaking or maybe speak some sort of like French or Creole. But I'm not a linguist, so I could be wrong on their languages. So I'm sure someone's going to like fact check me in the comments. That's one thing I do notice about social media. You could like, there's always someone that like knows the one
mhm.
thing that you didn't. uh,
That is so true. Yeah.
yeah, no, some now on some of my stuff, I have to put like qualifying like language on it and be like, usually this isn't a reaction that'll happen because if I said this won't happen, there'd be someone's like, actually, there's this one paper that shows if you like use some like really exotic catalyst, you can do this.
Yeah.
But no,
That
that's
is
great that you can, and I think you're right because I it's really like you talked about you got into like linguists a little or linguistics a little bit when you were learning Spanish, and like I always thought it's interesting how different languages like the way they think or like their idioms are different because even though like you think it would be standard, it would be the same across any languages, like they're all the same human brain, but like for whatever reason, the language shapes just like the way you think. So just to be able to talk to them in the same language means like even at like a in my mind it's like a subconscious level you're at least talking about like a more similar thing even if you were always talking about chemistry to begin with but you're both speaking in the same language the same mindset
Mhm.
so
Yeah.
yeah
Very cool.
so I think that's really how so are you so you're I guess fully fluent in Spanish then right.
Yeah, I feel kind of weird saying that because I still feel kind of like an idiot when I when I'm speaking Spanish, but like I all of my classes are in Spanish. I
Mhm.
give like my presentations in Spanish, and I would say like I'm at a level where it's very clear that I'm not Chilean when I'm speaking in
Mhm.
Spanish, but and there are some times where like I forget a word or something like that, but I don't have any like real issues.
Mhm.
Um, like I can defend myself. I don't have any real
Yeah.
issues communicating. Um, and so I feel confident.
Okay, that's that's awesome.
Um,
And I had some questions. You're you're Fulbright scholar. I think that's also,
mhm.
how did you? I think would be really interesting for people to how do you get involved in that? Like how did you apply? What was that application process like?
Yeah. So the Fulbright program is, again, I'm biased, but I think it's one of the US government's most successful and most important programs, especially when it comes to like education. Um, and so you can apply to the Fulbright program to go to, I think it's like 141 different countries around the world. And you can either apply to do research or to teach English. Um, and there's also a version for professors who wants to do like a sabbatical and do that. But for people that are just leaving undergrad or in graduate school, you can
Mhm.
either teach English or do research, um, basically anywhere in the world. And the inverse is true. They invite scholars from foreign countries to come to the US to do the same, to either teach. their language or do research. Um, and so being interested in Spanish and obviously chemistry, I knew that I wanted to do do both. I wanted to do chemistry in Spanish, and so I talked to one of my professors at my university, and he said that in South America, the best chemistry research is in Chile, Argentina, and Brazil. And so I don't speak Portuguese, and I really weighed my options between Chile and Argentina and decided on Chile. Um, Sorry, I got a little bit off track there. So the point is, the point is that the Fulbright program lets you do research or teach English. And it's one of very few of these sorts of big bilateral exchange programs that there are for the US.
Hmm.
Um, there are also a number of other really big scholarships like that, and I'm kind of blanking on some of them. I know that there's some others that are, I believe, run by the UK. I think it's, oh, the Rhodes Scholarship, I believe, where you go to the UK. There are those that you can apply for. Um, there's something called the Critical Language Scholarship, which is also a US program where they will send you to a number of different places. I think there's like 10 or 15 different countries on the list, and they'll send you over the summer to learn a language that is of critical importance to the US, which I'm going to apply for the next language cycle to
Yeah.
hopefully learn Portuguese before I go to Colombia. Um, and yeah, I think these sorts of programs are very important. I was very fortunate that my university, the University of Louisville, had a very like an expert national and international scholarships office, and my advisor there was very in the know about like all of the opportunities. And I think that that's one thing where there's like so many wonderful programs that you can apply for, but you just really need to sometimes you need to dig to look for them.
Hmm.
Um, and yeah, so that's my long-winded response.
I would agree. And like, especially because you don't know what you don't know. If you've never heard of the Fulbright Scholar, but how would you know to look for it? You know.
Mm.
So I think that's where, like you said, like Louisville, had like a great like a like office to help with that. And I think that's great. And I feel like with the internet, because like I'm older, so like when I applied to college, like there were some schools I just never even thought about because like I mean the internet obviously existed, but it was not to the extent that it does now. You didn't have like schools with these like social media campaigns like come to my school. So like I just applied to the schools that like were in my general region that I had heard about, or sent me a
Mm.
mailer. And so same with like any scholarships, like unless you knew someone that knew about it, you didn't know about to apply. And then now we have the internet where you can find it if you want, but I almost feel like um, it almost went the other way. Like there's too many things you could find, and now it could be like overwhelming for someone. Like which one of these do I apply to? Or oh, there's so much. Or because for like your Fulbright scholarship, what all did they require when you apply, when you like sent your I guess your packet in?
Yeah, forgive me, I didn't get
Oh,
into
you're
that.
you're
Yeah.
fine.
So uh there are a few different things. You need three letters of recommendation. You need a personal statement, a statement of grant purpose, and a host country engagement, as well as your CV and some other like various. It's like uh, there are three things. There's like academic awards, volunteer experience, and a third thing where it's just like other accolades that you have. So the statement of grant, or excuse me, the personal statement is basically like any personal statement. It's sort of who you are, what gets you excited, who you are as a person, like why you want to do this sort of thing, and why you're the good fit. The statement of grant purpose is exactly what you are going to be doing. So in my case, I was talking about synthesizing these metal helicates. Um, and I gave kind of a brief background on metal helicates and why this group in Chile is like why I want to work with them, and what I think I can accomplish and why that's important. And then the host country engagement is obviously this is one of the pieces of the Fulbright that was sort of when I first heard of the Fulbright, like was not immediately obvious to me, but after someone like kind of pointed it out, made more sense. Because not only is obviously this is an academic program, they want us to build bridges between the scientific community um, in, around the world and to the US. Um, but like in a small sort of way, I am also kind of representing the US here, and they want
Mhm.
to choose someone who is not just going to go to the lab and back home and to the lab and back home and not interact with anyone. They want someone who is going to make like a positive impact
Mhm.
and to be sort of like a mini ambassador for the US. And so you need to have like a thing saying, how are you going to get engaged with the community in the host country? And like, what are the sorts of things that you're going to do? And so this was kind of funny. I am a ballroom dancer.
Oh
And so
wow.
I talked about how there were a few different dance groups in Santiago that I wanted to join, and that I also wanted to learn cueca, which is Chile's national dance.
Mhm.
Um, and so I wrote an essay about that. I know one of my friends wrote about like getting into rock climbing here. There was one person who joined like a swim team. And so it really can be just the best way to write that section is just like talk about one of your hobbies and then find a group that is doing that in wherever you want to apply for. Um, and then say you're going to join it. And then once you get here, if you're selected, then obviously go do it. And it's so fun. Dude, it's crazy. The dance scene here is incredible.
Yeah,
Yeah, it's
that's
great.
awesome, man. That's so cool. I feel I feel you had a way better answer than me. They'd be like, "How would you, bond with the community?" Be like, I don't know. They like sports. I go to the bar, drink with."
Yeah.
But no, that's awesome that you do that, and then the ballroom dance. That's really cool. I think it's so cool when because people think of scientists, researchers, STEM, whatever you want to call yourself, these days. They think like, and to a certain extent, rightfully so, like we're not very good at being social. We're kind of weird. But when if you actually talk to someone, like as a general amalgamized whole, we are kind of weird. But the individual people are like usually a lot more normal than you'd think, and they have like very varied interests that you wouldn't think of. Like, you're a ballroom dancer. There's rock climbing. I feel like is I don't know about how it is there, but I feel like in Texas, like rock climbing is becoming very popular.
Oh yeah.
Um,
Yeah.
and everyone's just got some that you wouldn't think. You're like, wow, really? Like my one friend, grad school, she was from New England. Her high school had like a ski team and she did like downhill giant slalom in high school. I was like, what?
That's cool. That's so cool.
Um, yeah. So it's always cool that's awesome that you were able to write about that. And then, well, I'll ask one more question so I didn't take up more of your time. This one has nothing to do with science, but if someone wanted to come and visit Santiago, what's one thing you think they should go do
Oh,
or a place they should visit?
there's so many cool things to do here. Um, I really love Cerro San Cristobal. It's
Mhm.
this big hill. It's like I think it's like a little less than 3 miles to the top or something, but you just get this beautiful view of the city. It's incredible. Um, there are so many good places to go hike here
Mhm.
if you're into hiking. Um, so definitely some good hikes to be had here. Um, but there's a lot of really cool things to do in Santiago. I really love it here. It's a beautiful city.
That's awesome. Yeah, well, if anyone's listening, yeah, go to, and what was the name again? One more time. I'm so sorry.
Santiago?
The hill that you said?
Oh, Cerro San Cristobal.
Okay. Pedro San Cristobal. Okay. Well, I will keep that in mind if I ever go. I like to travel. That's like my hobby now.
Nice.
But Cal, thank you so much for your time. I really appreciate you doing this. For everyone, this is going to be on YouTube, so there's no way you could have jumped in late. But this is Cal Zirilli. He's currently working in Santiago, Chile, as part of his Fulbright scholarship. Thank you, Cal.
Thank you very much for having me. It was wonderful to talk to you.
You as well.